In the last video, we looked at cumulative probability functions and how to find a cumulative probability function given the probability density function. In this video, we're going to look at one or two more complicated probability density functions. Let's start with this one. The complication here with this probability density function is that it is defined in two parts. We have fx is 3/4 of x squared between 0 and 1, and 3/8 of 3 minus x, straight line, between 1 and 3. So let's go ahead and find the cumulative probability function. If we take the smallest value of x is 0, then the chances that we are less than or equal to 0 is 0. The cumulative probability is 0. 0 less than or equal to x less than 1. Well, f of x is going to be equal to the integral of 3x squared over 4 dx. That is x cubed over 4 plus c. And at x equals 0, that is the smallest value, f of 0 is 0, and in this case that gives us that c equals 0, and so in this region f of x, big F of x, is x cubed over 4. Okay, now let's look at what happens between 1 and 3. F of x is still the integral of little f of x. That now is something different. That is 3 over 8, 3 minus x dx. And if we integrate that, I'm sure you can cope with this, that is 3 over 8, 3x minus x squared over 2, plus some arbitrary constant, which I'll call c dashed. That is 9x over 8 minus 3x squared over 16 plus c dashed. Make the 8 just a little bit nicer. Well, we now need to find c dashed. You might remember from the previous video that as well as using that f of 0 is 0 when x equals 0 is the smallest value, if I use the largest value, the probability that x is smaller than the largest value must be 1. And so x equals 3 is the largest value of x. Therefore, big F of 3 must be 1. Big F of 3 is 9 times 3, that's 27 over 8, minus 3 times 3 squared, that's 27 over 16, plus c dashed. And if we work that out, we discover that c dashed is minus 11 over 16. And so in this part of the graph, between 1 and 3 for x, we get that f of x is equal to 9x over 8, better 8, minus 3x squared over 16, minus 11 over 16. For x greater than 3, f of x has to be 1. So to define capital F of x, to define the function, we need to summarize it as f of x equals 0 when x is less than 0, x cubed over 4, just at the top of the page on the right, when 0 is less than or equal to x is less than 1, fx is 9x over 8 minus 3x squared over 16 minus 11 over 16 when x is between 1 and 3, and big F of x is equal to 1 when x is bigger than 3. So there is my definition of capital F of x. And the graph of this cumulative probability function is here. Notice that it takes over smoothly at the end of each interval. Between 0 and 1, it's x cubed over 4. When x is 1, the next part of the graph, 9x over 8 minus 3x squared over 16 minus 11 over 16, takes over with the same value. That is going to be something that we're going to come back to in the next example. That each time we get to the end of an interval at the top here, when x is 3, this function has got to 1, this one starts at 1. At this point, this function, x cubed over 4, has become a quarter. This one, if you put x equal to 1 in, you would discover starts at a quarter. Okay, let's look now at another example. One more complication coming in. In this case, we have a probability density function which is defined in 3 non-zero parts. 3 non-zero parts. This is why I prefer method 2 in the textbook, the one which uses the plus C approach. I think that it's actually easier to cope with an example like this. Well, let's look about finding the cumulative probability function. For x less than the smallest value, f of x is going to be 0. Let's have a look between 0 and 1. F of x is going to be the integral of little f of x, which is 3x squared over 10 dx, and that is x cubed over 10 plus c. X equals 0 is the smallest value. Therefore, f of 0 is 0. And if we do that, we find that if we put x equal to 0, c must also be 0. And so in this case, we have that big F of x is equal to x cubed over 10. So that's what happens between 0 and 1. Let's have a look now between 1 and 3. F of x is still the integral of little f of x. Little f of x now is 3 over 10. And so this is 3x over 10 plus our arbitrary constant of integration, which I've called c dashed, so I don't confuse it with c. This is where I'm going to use the idea that I pointed out at the end of the last example. The interval 0 to 1, so in 0, 1, f of x ends at f of 1, or as close as you like to it if you're going to be particular, and therefore f of x ends at 1 over 10. 1 cubed over 10 is 1 over 10. Well, if that's where that interval ends, in the next interval is 1 to 3, f of x must start at f of 1 equals 1 over 10. Where my cumulative probability finishes in the first interval, it must start at the same point in the next one. Now I have an equation which allows me to work out c dashed. So here I've got 3 times 1 over 10 plus c dashed is equal to 1 over 10, and that gives you that c dashed is minus 1 over 5. Okay, let's just summarize that. That gives us that in this interval, f of x is equal to 3x over 10 minus 1 over 5. So we were using that idea that at the end of the first interval, the cumulative probability that we are less than 1 is 1 over 10. At the start of the next interval, we can't have suddenly changed the cumulative probability. It must still be 1 over 10. That is the idea that we need in order to work out c dashed. In the last interval, which is still just at the top of the page, 3 less than or equal to x less than 5, f of x, capital F of x, is still the integral of little f of x, which is the integral of 3/4 minus 3 over 20x. That is 3x over 4 minus 3x squared dividing by 2 over 40 plus c double dashed. Now I've got two possibilities here. I could say that at the end of the interval 1, 3, I must start the next interval at the same point. Or I could say, which is easier, that x equals 5 is the largest value, which gives us that f of 5 is 1. And putting x equal to 5, that gives us that 3 times 5 over 4 minus 3 times 5 squared, so a better 5 than that, over 40 plus c double dashed is 1. And if we do some lightning arithmetic on that, we get that c double dashed is minus 7 over 8. And so in this region, f of x is equal to 3x over 4 minus 3x squared over 40 minus 7 over 8. We can summarize all that, and I've already done it for you, that f of x, capital F of x, the cumulative frequency must be 0 when we are smaller than the smallest value of x. Between 0 and 1, we showed that it was x cubed over 10. 1 to 3, 3x over 10 minus 1 over 5. Between 3 and 5, 3x over 4 minus 3x squared over 40 minus 7 over 8. And when we are larger than the largest value, the probability of being smaller than x must be 1. Now let's have a look at the sketch. And there we have it. 0 below, x cubed over 10 up to here. Smooth takeover again. That's what gave us our value of c dashed at the time. Straight line, 3x over 10 minus 1 over 5, till we get to 3. And then a parabola, quadratic, up to 5. And then afterwards, 1. So those two examples are just a little bit more complicated. They're not difficult, and I really do recommend using the method of integrating with plus c in it. You can find more on this in your textbook, S2, on pages 43 to 48.